Is it actually? It's the winter arc. Oh, shoot, I gotta retake it. Winter arc, that's the thing. I mean, winter arc starts today. My mom won't let me on it.
Hey, check it out. It's October.
Man, I said I love you. Yeah, I did. I always just said that.
Please excuse the interruption. This is a reminder that there will be no bells and no paging this morning. Thank you.
Thank goodness. Negative plus or minus square, b squared minus 4ac all over 2.
What a way to start the morning. Kanye just hit us up with the song. That was good. You guys should all vaguely at least remember, probably ninth graders are going to remember a little more from last year because you did it 5 months ago, 4 months ago, whereas 11th graders for you, it's been like a long time, like 17 months or something. So anyways, Kanye nailed it, and we're just going to write it on the board. Since this is not your first time learning this, we're not going to make this take too long. I'm assuming that once it comes back on the board and we start working with it, that it'll just be like riding a bike. And so remember that when you're trying to solve a quadratic equation and you're not sure that it can be factored, which is what's going to start happening tomorrow in our polynomial problems, then we have this wonderful formula, capitalized. It's a proper noun, quadratic formula. We use it to solve quadratic equations. It works on quadratics that are factorable, FYI. You'll see that in the notes. But it's primarily used when we're thinking factoring is not an option. So before we get started on doing this problem, let's remember what it is. And remember that it says that your x values, or whatever variable you're solving for. I know in the Delta math today, you'll get A's and M's and W's, and so it doesn't matter. This is just whatever you're solving for equals. And then the top of it is the opposite of B, plus or minus the square root of B squared minus 4AC. And then we divide all of that. Make sure your division sign encompasses the entire thing, right? All of that is divided by 2A. So the only person in this room that I could say maybe doesn't know that would be back there in the corner, since I was not her Algebra 1 teacher. But I'm obviously certain that there's no way you got through algebra. Oh, and Hugo as well. Sorry. There's no way you got through algebra 1 and didn't learn the quadratic formula. So anyways, we need to know who A, B, and C are. So you're going to commonly see throughout this assignment, at least, this won't be so much of a thing during our application of this for polynomials, but for today, your quadratic is not ready to solve. Do you remember why? Why is the white quadratic up here not ready for the quadratic formula? Because it doesn't equal 0. Very good. So step one is make sure it equals 0. And in this case, what that means is we want to take the -2 and add it over, move it over to the left. So our actual quadratic is 4x squared minus 5x minus 4. And then set it equal to 0. And now we're ready to rock and roll. So what would we say is A? Yeah, so A is just 4. Okay, so remember, just the numbers are the A, B, and C. No X is allowed. What's B?
-5.
Nice. And what's C? Good. And then it's just a matter now of plugging these things into the quadratic formula. I'll caution you, and I'll say this more than once, that this is a minefield of basic skills errors. It can be. You want to, yo, Stasher, you want to kill those lights? It's too bright in here right now. Oh yeah, that's good. So anyways, I'm cautioning you that it's not, what I find is it's not so much that students go, oh, I'm having a hard time with the quadratic formula. It's like, no, you're not. You're having a hard time with basic math. And so just some basic things to remember. This thing that I'm circling up here is always positive. Got that? Because whether B's negative or positive, it doesn't matter. When you square it, it will go to positive. So if you use your calculator for some bigger numbers, just remember to not even put the negative in. Because like if you do -17 squared, you know it's going to be positive. So just type it in as 17 squared. And then the other thing to watch out for is commonly right here where this arrow is pointing. I don't know if you remember this, but that C value can be negative, like it will be in this problem. What happens when the C is negative? Let's take a look. So we're going to take these three red numbers and we're going to plug them into the quadratic formula, and it's going to say, here we go, x equals. The first thing we do is take the opposite of b. What would that be in this case? Positive 5, and then we write plus or minus, and then we draw a big long square root sign. As long as you think you want it to be, it's probably not long enough because there's stuff we got to put in there. And then the first thing you encounter just right out of the gate is b squared. What is b squared? Good. It is always positive 25. I mean, no one should be using their calculator for negative 5 squared. No one past the age of 9. But if you do, remember to type it in just as positive 5 squared, right? Because the negatives are just going to go away anyways. And then I'm going to put minus 4. And then what I like to do is put just 2 blanks. If you sat through this, you remember this about me. And then I come back to that later, and then I put it all over. And this math I do. What is 2 times a? 8. 2 times 4 is 8, right? And now I'm going to go and I'm going to backfill my 2 parentheses. And who goes in those? Careful. It's a times c. Good. So a becomes 4 and c becomes negative 4. Now, what's important for us to note here is that there's a minus sign in it's called the discriminant, by the way. I don't care if you know that, but the stuff inside the square root is called the discriminant. And if the discriminant has a minus here, which it always will, and it happens to encounter another negative here, which it sometimes will, then the minus sign actually changes to a plus sign. And what's inside the square root sign in this case actually winds up being 25 plus 64. Because I did 4 times 4 times 4, which is 64. And again, you might, if you say, where did the minus or the negative go? You're just not listening, right? The minus and the negative, they find each other eventually and become just addition. So you've heard the expression like, keep it simple, stupid, right? So don't overanalyze the whole negative thing. Bottom line is it's either going to be 25 minus blah, 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 or 25 plus blah, blah, blah. And that's just contingent on the signs. So this is an example of a quadratic formula problem that's actually already just about done. This one's going to be done here in about 15 seconds. So we're going to say x equals 5 plus or minus the square root of 89. All divided by 8. Okay, everyone see where 89 came from? B squared, because I just went ahead and did the math inside. I did that yellow math problem that's up in the kind of the top right side of the TV there. That's what I did. And the thing is, there's 3 possible things that can happen. Well, technically 4, but there's primarily usually 3 things that can happen. Number 1 is that root can be dead, which 89 is dead because you'll recall like it can't break down into 2 different roots. And it's certainly not a square rootable number. So in a case like this, our answers are right here. And I'm not going to write this every time. I'm going to write this once, but I need to be perfectly clear. How many answers are in this box? There are 2. It's very important that you understand that. Now, most people are not generally going to ask you to write them both, but again, I'm going to write this one time. And the answers are x equals 5 plus the square root of 89 over 8. And the other answer is x equals 5 minus the square root of 89 over 8. To be clear, those are different entities. We just write them together because we can. So it's opportunistic, I guess. Take advantage of that. So that's example 1, and that's just a refresher on how you use the quadratic formula. So I've got a ton of these, and we're going to go through them not particularly slowly. So let's do another one that will feel similar to that. Let's do 2x squared minus 4x plus 4 equals 3x. So what will we do first? Bring over the 3x, right? And this, again, there's no place in this class for rinky-dink garbage like coming up with -4 plus 3, right? When we move the 3x over, we're actually subtracting it. So we wind up with 2x squared minus 7x plus 4 equals 0. And then we're ready to rock and roll. Who's A? Who's B?
-7.
And who is C?
4.
Nice. And I'm not going to keep rewriting the purple quadratic formula every time. I assume you jotted it down in your notes. And so now we're going to plug those numbers into the template. And here we go. We're going to say x equals. What's the first thing we do? The opposite of b. And remember, when we sing the song, you know, the quadratic formula is negative b. That first part comes out as negative b. But you have to remember that, I mean, that does not mean that what you put there is a negative. It means it's the negative of potentially an already negative. So that's why it's safer when we just are conversational about this to just call it the opposite of b, so that we don't do anything crazy. So yes, it's going to be a +7 because that's the opposite of -7. And then we're going to put plus or minus a long square root sign. What's the first math answer in here? Yeah, +49. And then again, I'm always going to put -4 blank blank. And I'm going to come back to that in about 20 seconds. And I'm going to put it over 2 times a, which is 4. 2 times 2 is 4. Now I'm going to go backfill my blanks with A and C. And the first blank will be a 2. And then the second blank will be a 4. What can you tell me about that minus sign with the little yellow arrow? Is it going to stay a minus or change? It's going to stay, right? It has no reason to change because it doesn't encounter another negative afterwards. So the mathematics inside in the discriminant here is actually, in this case, just 49 minus 32. And that's just the math. I'll put a yellow oval around it. If you just multiply those numbers, 4 times 2 is 8 times 4 is 32. And so again, this one is one step from done because we're going to just have a root that is just dead. We get 7 plus or minus the square root of 17, all divided by 4, send it, done. Okay, so for the next two examples, I'm going to change it up a little bit. So that's one type of a quadratic outcome where you get a dead root. Those are the best because they're just quick, like boom, get in, get out kind of thing. For these next couple of examples, something is going to be a little bit different, and we'll discuss that right when we get there. So this one is going to be 3x squared minus 7x minus 4 equals -5x. What do we do first? Bring over that 5x, right? What's it going to say? Right. Yeah, so 3x squared minus 2x minus 4 equals 0. And just FYI, I'm never singling anybody out. I'm just this is a generalized statement for all of you in this room. If you are vexed by the minus 2x, you're a good candidate for someone who's still in the let's show our work step. I just don't do it at this level anymore, but that is the math that we're doing. So if you're prone to coming up with something wrong there, just show the work when you move something across and you'll be fine. All right, so A is 3. B is, C is, yeah, so you already know because of the C value that this is going to be a switcher. The minus inside the discriminant is going to change to plus. If we play our cards right, A is never going to be negative. I mean, we're in control of that by where we put things. So it's just C that you generally want to watch out for. So we're going to say X equals the opposite of B. So 2 plus or minus a big long square root sign. And inside the first math thing we get is -2 squared. So B squared comes first, and that is +4. And then I'm going to put -4 blank blank. And then I'm going to come down here to the bottom and do some little rinky dink math where it's 2 times 3, 6. And then I'm going to backfill my blanks with A and C. A is 3, C is -4, and that should raise a red flag, right? The fact that there's a minus right here, which again, there always will be, and then he's like, oh, look, there's a negative later, then that means they're going to come together to make plus. So what's happening in the discriminants is actually 4 plus 48. And again, that's just me multiplying these three numbers in the yellow oval together. Don't make a mountain out of a molehill here. Just figure out what the sign is and then multiply the three numbers. 4 times 3 is 12 times 4 is 48. This one will not be a quick get in, get out because the discriminant this time is a thing. What's significant about the square root of 52? Unlike his predecessors, Say again? Yeah, and it's not even just doesn't, you're right. I mean, it doesn't just have to be a prime, but it has to be a dead root, and 52 is not a dead root. So if you went through my class Algebra 1, we spent probably a couple of days and did like 100 of these, where hopefully this comes flooding back to you. If I take the square root of 52 and I break it down, I couldn't have done this with the last ones. What were they like? Were those like 17 and like, what was the other? 89. Like those are trash numbers, right? But 52 says, hey, look at me. I'm pretty awesome. I can be built by 4 times 13. And I made the 4 red. Why? Because it equals 2. And that's how we break down radicals. It's not like it's an optional thing. It's not like you just do it in this class. It's just what math people do. It's no different at this point in your life than the expectation that you'll reduce a fraction or simplify 2 plus 2 to make 4. So the actual value of the square root of 52 is 2 roots of 13. So what we're going to do is we're going to take the 2 roots of 13 and we're going to put it there in place of the root of 52. Rendering our answer in need of more work. So we're going to have 2 plus or minus 2 roots of 13 all over 6. And you might remember the Dorito that I have you draw. It's again, the Dorito is something, if you went to like some college professor, they'd be like, what is this Dorito you're talking? Like, it's just a dumb thing I came up with. But the idea is you want these numbers in this triangle to be divisible. And if they are, then you want to simultaneously reduce them all. What can they all be divided by? Which leads us to our answer, which is x equals 1 plus or minus 1 square root of 13 all over 3. And of course, you notice that I did not put the 1 in front of the root, because like, who does that? You can, it's not wrong, it's just weird. So the places where you wouldn't put a 1 are in front of the root, and if you happen to get one on the bottom. Is it all coming back to you? All right, let's do another one. X squared plus 10x plus 4 equals 0. Hey, good news. It's already set equal to 0, so we can save like 22 seconds. Let's hop in. What's A? A is 1. Remember, A will never, ever contain, not until you take some crazy math class like 7 years from now. A will never contain an actual variable. It's just numerical. So A is an invisible 1, B is, and C is, and we're in. Here we go. So X equals what's first? Negative 10, the opposite of B, plus or minus the square root of, what goes first? 100. B squared is 10 squared, 100 minus 4 blank, blank, all divided by double A. In this case, 2 times 1 is 2. Now we got to go backfill those AC blanks. What's going to go in place of A? C. Is this a keeper or a switcher? This is a keeper, right? This minus is going to stay like he is because he has no reason to change. What is 4 times 4? 4 times 1 times 4, 16. So inside the discriminant, we actually have 100 minus 16, which is 84. Nice job. So we have negative 10 plus or minus the square root of 84. And again, it's my job and your job, collectively everyone's job, to look at the radical and ask yourself, can I break it down? And the answer is yes. What numbers do you use when you break down the square root of 84?
6 and 12.
6 and 12 make 72.
Oh. 7.
7 and 12 is correct, but incorrect. 7 and 12 is awesome because kudos to you. It does multiply to make 84. But why are 7 and 12 dead to me? Because neither of them's rootable, right? Remember, when we break these down, we're not doing it arbitrarily. Like, we're looking for numbers that are square rootable. There is one pair that works to make 84 and is square rootable. There it is, Steve. 4 times 21. So the square root of 4 is 2. And so we're going to write this now finally as 2 roots of 21. And again, this green box is going to go right back in and replace this green box. That's the gist here. So the almost done answer is x equals -10 plus or minus 2 roots of 21 all over 2. And again, if we employ the thinking about the guacamole flavored Dorito, what can all those numbers be divided by? 2. Sometimes they won't be divisible. The Dorito isn't like a guarantee. It's just a little visual cue to remind us to look for divisibility. So we have x equals -5 plus or minus the square root of 21. Done. And again, the idea is when these two numbers that I'm circling in white become ones, they're unnecessary. The only time a 1 is necessary is in the first spot. That's a placeholder. The others are just optional. If they're ones, they're dead. The final part of this lesson, and I know you probably want to be done, but there's a little bit more I wanted to point out. And sometimes what happens in math is we go to do the quadratic formula only to realize that, oh, snap, I didn't need to do the quadratic formula. It's more common than you might think. So let's say we got to the end of one of our polynomial problems and we got the 3 numbers below the synthetic division sign are 8, -14, and 5. A lot / most people would look at this and just say, I don't even want to try to factor that. If it doesn't look fun, I'm just going to pop it into the quadratic formula. Quadratic formula is a nice, like, lazy man standby. Like, just, it always works. If you don't mess it up, it always works. So let's get into it. What's A? B, C. So here we go. And we go into this not really expecting what's about to happen, but it happens. And so my x is going to equal what? +14 plus or minus a big long square root sign. And inside the square root sign, what's the first thing we get? I agree. 196. Okay. And that's where you run into risk. Some of you guys, I see a lot of people reaching for their backpacks and grabbing a calculator, and you've been warned. If you, like a knucklehead, type that into your calculator, it's going to say this. And it's not because it doesn't know, it's because you forgot the parentheses. So again, I'll give you my advice. Just leave the stupid negative off because you forgot to put these parentheses on. And that's why the calculator would give you a negative. So just that's where it happens right there. I'm not opposed to using your calculators, just use them right. So we're going to have 196 minus 4 blank blank all divided by 2 times A, which is 16. And I'm going to backfill A and C with A and C. In this case, 8 and 5. Is that a keeper minus or a switcher minus? He's a keeper. He's like, I'm not going anywhere. And then I got to do some math. What is 4 times 8? 32. What's 32 times 5? It's 160. And 196 minus 160 equals what? 30. Yes, very good. So we have x equals 14 plus or minus the square root of 36. So this kind of concludes the idea of, there's always 0, by the way, and I don't think that's going to happen, but if it does, let me know. But there's 3 things generally that the root's going to be. It's either going to be dead, like our first 2 examples. It's going to have some meat on the bone, like our next 2 examples, or it's just going to be straight up, I'm out. What is the square root of 36? It is just straight up 6. And so in a case like this, we're not going to draw like a dumb little tree. We're going to just say that x equals 14 plus or minus 6. And if you've been in my class, you'll remember I refer to these as pathway problems because the way I view it, and I think it sticks with some people, is I view this now as there are 2 pathways that I need to walk. I haven't walked this pathway in the previous 4 examples because I couldn't. If I said to you, like, what's 5 plus root 2? You just go, what's 5 plus root 2? Like, you can't go further because those are not like simplifiable like terms. However, the first pathway that I'd like you to consider is the word plus. If you trace that pathway, what is 14 plus 6? So one of our answers is 20 over 16, which we will, of course, reduce. The other pathway that we can trace is the minus. It is literally, it's like a choose your own adventure. Like you can pick this way or this way, and you do them both. What is 14 minus 6? So the other answer is 8 over 16. So when we state our answers now, we don't state these using a plus or minus sign. These are separated answers where you'd need two answer boxes in delta. Our answers are x equals 5/4 and x equals 1/2. Got it? And I'm gonna, everybody doing okay? Let's do, I'm gonna do two examples. I only have one on the note card, but I'm gonna call an audible and we're gonna do like an ending just in case, because I can sense that this might be one of those Mr. Ahern days where I leave something out and then it happens to you. So let's do this one. This one is scripted on the note card. The other one I'm just gonna kind of freestyle, but 3x squared minus 10x minus 10 equals 3x. Let's do this. Bring that 3x on over a la izquierda. So we have 3x cuadrado menos 13x menos 10 igual a 0. Let's do it. What's A?
3.
What is B?
-13.
What is C? Dope. Here we go. X equals what? 13 plus or minus the square root of what? 169 minus 4 blank blank all divided by 6. I'm going to backfill A and C with 3 and keeper switcher. It's a switcher because the minus is going to say, there's a negative over there. We're going to find each other. Let's just do this right now and just get it done with and make a plus. So what we have inside the square root sign is actually 169 plus 120. 4 times 3 is 12 times 10 is 120. Keep it simple, stupid, right? Don't be laboring over those signs. You see people typing negatives times this times negative, and it's like, man, I'm failing you, right? Just figure out the sign, then do the math. Easy peasy. What's 169 plus 120?
Oh, I thought it was just 289.
All divided by 6. And then 289, you either recognize it because you just know it, or you recognize it because you're going to have those resource sheets probably out and handy, and you're going to go, hey, I know 289. What is the square root of 289? It's really not that big. It's on your sheet. It's 17. It is what it is. It's no different than saying like the square root of 16 is 4. The square root of 289 is just straight up 17. And so when we simplify this and we rewrite it, we're going to say x equals 13 plus or minus 17 over 6. And this is where we go the splitsies pathway. So what is 13 plus 7? 30 divided by 13 plus 17 is 30. 30 divided by 6 is 5. My bad. I probably did. And then I'm going to take the bottom pathway, the low road. What's 13 minus 17? -4. And then I'm just going to write my answers out formally. I'm going to say x equals 5 or x equals -2/3. So this last one is me calling an audible. I'm just line of scrimmage. I realized something's happening. So let's say we get to the end of a quadratic formula and we get like this. We get x equals, I don't know, I'm just going to make this up, like -8 plus or minus the square root of 16 minus 4 times 1 times 4, all divided by 2. If this happens to you, then I can say, yes, I covered it. If it doesn't, then okay, it never happens, but it will sometimes. So what's interesting is obviously the minus is a keeper. And what is 4 times 1 times 4? And so the discriminant in this case is 16 minus 16. And what does that equal? Right. So something interesting happens in a problem like this. You say -8 plus or minus, what's the square root of 0? 0. And what happens is Nothing. What happens when you add 0? Nothing. What happens when you subtract 0? Nothing, which renders this entire portion pointless, which means we just have one answer, which is x equals -4. Done. That would be what you would see on one of those bounce roots that we talked about, because that means you're getting -4, but actually it's counting twice. So there, covered it. Any questions about the quadratic formula? Your assignment is on the delta math. You're obviously going to need paper, whiteboard, whatever. Good? All right.
Slay.